Hey everyone, Bob here. Today, I'd like to explain to you the function of the alternator and the charging system of vehicle. But first, I'd like to mention that this presentation is intended for technicians, mechanics, and other enthusiasts. Alternator is driven by the engine along with other components like aircon, compressor, water pump, power steering pump, and sometimes air injection pump for gas emission control purposes, like to lower hydrocarbon and carbon monoxide emissions. The purpose of the alternator is to supply current to recharge battery and power the electrical accessories in the vehicle. Alternator operation is extremely important to provide proper operation of the electrical components and accessories and maintain the battery in a fully charged condition. If the alternator voltage is too high, it forces excessive current flow through the electrical components and accessories and the battery, resulting in damaged electrical components and excessive battery gassing. But when the alternator voltage is too low, it does not supply enough current to the electrical accessories and the battery. This may lead to improper operation of some electrical components or accessories and the charged battery. The alternator contains a rotor and a stator mounted between two end housings. Bearings in the end housing support the rotor shaft and allow rotor rotation. The drive end of the rotor shaft extends to the drive end frame and the pulley is bolted or pressed onto this end of the rotor shaft. A cooling fan attached to the belt pulley forces cool air into the alternator to cool it. Cooling fans are often built into the case to aid in dissipating heat. The cooling fan rotates with the pulley to move air through the alternator and cool the alternator diodes. A drive belt, or sometimes called a serpentine belt, surrounding the alternator pulley and the crankshaft pulley rotate the rotor. The drive belt may be also drive other components such as power steering pump or air conditioning compressor. The stator is mounted in a frame and is bolted between two end frames so that it is stationary. The stator contains three insulated windings mounted in stator frame slots. There's a very small clearance between the rotor poles and the inside diameter of the stator frame. A rectifier plate is mounted in the slip ring end frame. An insulated field winding is mounted on a spool that is pressed onto the rotor shaft. Two metal poles are pressed onto the rotor shaft on each side of the winding, and these poles have interlacing fingers positioned above the winding. Two insulated copper slip rings are mounted on the end of the rotor shaft, and the ends of the field winding are connected to these slip rings. In some alternators, both brushes are insulated and connected to the two alternator field terminals. In other alternators, one brush is grounded and the other brush is connected to a field terminal. The stator assembly contains three insulated windings. These windings are mounted in insulated stator frame slots. Some stators have Y-connected windings, and in other stators, the windings are delta connected. Y-connected stator windings have three ends of these windings connected together in a Y-shaped connection, and the other ends of these windings are connected to the diodes. In a delta-connected stator, the end of the one stator winding is connected to the next stator winding. In this type of stator winding, the junction where each pair of stator windings is connected is attached to the diodes. A diode is made of two semiconductor materials joined together. A semiconductor material is usually manufactured from silicon. In the manufacturing process, the silicon is mixed with other elements such as boron and phosphorus. The unique mixture of semiconductor materials allow current to flow in one direction only. This may be referred to as forward bias. Since alternators produce alternating current, it must be converted to DC or direct current before leaving the alternator and put into the car's electrical system. Groups of diodes are used to rectify the current so all electrons are moving in the same direction. Generally, there are 6 diodes used to rectify current in an alternator. 3 are put in forward bias to allow current to pass when the polarity is positive. 3 diodes are put in reverse bias so that when the alternating current has switched polarities, they do not allow the charge to change direction, effectively converting AC to DC by changing the direction of the current flow to one direction only. A rectifier assembly containing 6 diodes is mounted on a heatsink in the slip ring end of the alternator. 3 of these diodes are mounted on the insulated plate that is connected to the alternator battery terminal. The other 3 diodes are mounted on the side that is grounded to the end frame. The ends of the stator windings are connected to the diodes. The alternator battery terminal is connected through a 12-gauge wire to the positive battery terminal. Therefore, battery voltage is available at the alternator battery terminal with the ignition switch off. A fusible link is usually connected in the wire attached to the alternator battery terminal. This fusible link protects the battery wire and wiring harness if this wire is accidentally shorted to ground. In alternator circuits, voltage is supplied from the ignition switch to the alternator field terminal when the ignition switch is turned on. Current then flows through the insulated brass, slip ring, field winding, and the other slip ring and brass to the ground. This current flow through the field winding creates a magnetic field around the rotor. The interlacing fingers on one side of the rotor become north poles, and the interlacing fingers on the opposite side of the rotor become south poles. The magnetic lines of force travel from the north to the south poles in the interlacing fingers. When the engine starts, the rotor revolves inside the stator and the rotor magnetic field cuts across the stator windings. Notice that the rotor poles around the circumference of the rotor are alternately north and south poles. Therefore, each stator winding is influenced by a north and a south pole, followed by a south and a north pole. When the alternating magnetic poles on the rotor cut across a stator winding, an AC is produced in the windings. Since the battery and electrical accessories on the vehicle must be supplied with DC or direct current, The AC or alternating current in the stator windings must be rectified to DC. This rectification is accomplished by the alternator diodes. The diode changes the AC current in the stator windings to flow of DC current through the battery and electrical accessories. Modern vehicles are equipped with electronic voltage regulators. These regulators are often mounted inside the alternator on the outside with the alternator end frame, or in the vehicle's PCM, powertrain control module. If the voltage regulator is mounted in the vehicle's PCM, the operation is generally the same as to how the charging is controlled in internal voltage regulated alternators. Electronic regulators are non-adjustable. Some older vehicles have electronic regulators mounted externally from the alternator that could be adjusted. However, when they need repair, they are generally replaced with newer and non-adjustable regulators. Electronic voltage regulator circuits vary depending on the vehicle. Always use the charging circuit wiring diagram for the vehicle you are working on. For most vehicles, the regulator circuits work similarly. When the ignition switch is turned on, current flows through the ignition switch, charge indicator bulb, and parallel resistor to the corresponding alternator terminal. From this location, current flows through the integral electronic voltage regulator, slip rings, brushes, and field coil, and the transistor in the regulator. Current flows through this transistor to ground. This current flow creates a magnetic field around the rotor. When the engine starts, the rotor magnetic field induces voltage in the stator windings, and current begins to flow from the stator windings through the rectifier to the battery positive terminal. Current also flows from the stator windings through the diode trio in the alternator. Under this condition, equal voltage is applied to both sides of the charge indicator bulb, and this bulb goes off. Current also flows through the diode trio on the slip rings, brushes, and field coil to TR1 or transistor 1. Since TR1 is turned on, current flows through this transistor to ground. Under this condition, field current and rotor magnetic strength are higher and the voltage in the stator windings increases. The diode trio is a small assembly containing 3 diodes. These diodes are connected from the stator terminal to the number 1 terminal and prevent alternating current from passing into the regulatory circuit. The alternator number 2 terminal is connected to the positive battery terminal. Therefore, alternator voltage is sensed at this terminal when the engine is running. When the alternator voltage reaches a predetermined value, TR2 in the voltage regulator is turned on and TR1 is turned off. The regulator typically limits the alternator voltage to between 13.8 volts to 14.8 volts. Resistor R2 in the voltage regulator is a thermistor with a parallel resistor. The thermistor allows the regulator to provide a higher alternator voltage when the atmospheric temperature is cold. This action compensates for additional resistance in the battery when it is cold and maintains the charging rate from the alternator through a cold battery. A thermistor is a special resistor that changes resistance in relation to temperature. So when the thermistor is cold, is resistance increases. That's all the lesson for today. And the next lesson related to this topic is about charging system maintenance and diagnosis. If you happen to like this video, please do subscribe and hit the notification bell so you'll be notified of the next video upload. And thank you for watching.